This is a recording of a presentation originally given at Spectra QEST's 2020 North American User Conference about the digital sealing functionality introduced in Construction Hive with the latest release 1.900. This presentation goes into the details behind digital signing technology, how we selected the partner that we did to deliver this functionality, as well as why we made some of the decisions that we did in delivering the functionality. We'll start off by talking about some general information around sealing documents. Reports must sometimes be sealed by a professional engineer. In the case of construction materials test reports, this is often regionally based and based on customer type. When working for government departments or DOTs, for example, this requirement comes up more often than working for private firms. The National Society of Professional Engineers says that the act of signing and sealing engineering documents signifies that the work was prepared by the professional engineer or under their direct control or personal supervision. The signing and sealing professional engineer is of the opinion that the documents contained meet usual and customary engineering standards of practice, and the documents are appropriate for review and approval by the appropriate code enforcement official. This statement means that when sealing a document or stamping a document as a professional engineer, this is really more stringent than reviewing test reports for trends in data or data entry mistakes. Boards of engineers from state to state define requirements around professional engineering seals. This includes things like appearance and what must be included in the seal, the size of the seal when it appears on a document, but importantly, how to treat an electronic version of the seal. Now, the requirements do tend to differ from state to state, so let's take a look at some examples. The California Code of Regulations states that the seal may be obtained from any source and shall be capable of leaving a representation or an electronically generated representation on the document. This is actually quite lax, and it means that a simple image of the seal is sufficient. The Texas requirements are a little more interesting. They talk about license holders taking steps to ensure the security of their electronic seals and electronic signatures. Additionally, these language specifically calls out electronic seals and signatures being composed of files, and there being reasonable security measures taken by the engineer to protect these files. And if the files are lost, the engineer must notify the board of the facts concerning the loss. This implies that a simple image is not sufficient here. Indiana defines an electronic signature as an electronic sound, symbol, or process logically associated with an electronic record and executed or adopted by a person with intent to sign the electronic record. Again, pretty broad, and a simple image would arguably fit this definition. Michigan is similarly broad. It means a seal created by electronic or optical means affixed to the document or electronic document. Again, no real stringent requirements there. Ohio starts to get interesting. The red bit of text in the code here states that the electronic signature must be unique to the person using it, capable of verification, under the sole control of the person using it, linked to a document in such a manner that the electronic signature is invalidated if any data in the document is changed. We can pretty quickly and pretty easily see that a simple image in this case will not meet these requirements. Maryland has very similar requirements. Contains identification and unique to the licensee using it, is under the exclusive control of the licensee, cannot be repudiated, and is independently verifiable, and is linked to the document in such a way that any subsequent modifications will invalidate the document. Virginia, similar requirements. Unique identification of the professional is verifiable and under their direct control. North Carolina, again, unique to the licensee, capable of verification, under the sole control, and linked to the document in a manner that tampering invalidates the document or the signature. South Carolina is a little more lax. An electronic record or electronic signature is attributable to a person if it is the act of the person. The act of the person may be shown in any manner, including a showing of the efficacy of a security procedure applied to determine the person to which the electronic record or electronic signature was attributable. Now, an image in this instance may not be sufficient, but a system that somehow modifies the document that is in a way that is unique to the person with decent security measures, logins, etc., may be passable here. But the language is quite broad. And finally, as our final example, Florida. These are the more stringent requirements we've seen before, unique to the person using it, capable of verification, under the sole control of the person using it, and linked to a document in such a manner that the digital signature and document is invalidated if any data in the document is changed. So let's take a step back and take a minute to define the difference between electronic signatures and digital signatures. An electronic signature was really well encapsulated in the Indiana requirements. It is created by electronic or optical means and affixed to a document by somebody with intent to sign the document. That's all that's required. And this can be as simple as clicking a box, filling out a form field, attaching an image. So long as I intend to sign the document with that action, that is sufficient. A digital signature meets each of those following stringent criteria that are in some of those boards of engineers requirements around seals. Being unique to the licensee, able to be verified under their sole control, non-repudiable, and linked to the document such that tampering invalidates it. So a digital signature is still an electronic signature. It still meets the definition of an electronic signature, but is also more stringent. It provides a higher level of confidence about the signing process and about the signer themselves. But from that, we can say that if a state allows an electronic signature, then since a digital signature is an electronic signature but better, then they'll also allow digital signatures. Now, there are three types of seals and signatures allowed for by PE boards in the United States. Hawaii only allows wet signatures, so Hawaii is out for this discussion. 13 states have requirements in their boards of engineers that will allow an electronic signature to be used for sealing digital documents. 36 states plus DC allow digital signatures. So 49 out of 50 states will accept a digital signature. From the examples we looked at before, California allows an electronic signature. Texas is a little bit unclear, so we'll put them in the middle for now. Indiana is fine with an electronic signature. So is Michigan. Ohio definitely requires a digital signature. They require that higher level of confidence, that higher standard of security. As does Maryland, Virginia, North Carolina. South Carolina falls in the middle again. It was a little unclear. And Florida definitely falls on that right-hand side. Now, out of those two states in the middle, the interpretation I would take is somewhere like this. Texas leans more towards the digital signature side of the requirements, whereas South Carolina probably leans closer to the electronic signature side of the requirements. So how do digital signatures work? Now, these requirements, the stringent requirements for digital signatures, can be met through the use of digital signing algorithms and public key infrastructure. And public key infrastructure works like this. So you have a signer, digital signing algorithms work like this. We have a signer who has a document that they wish to sign and pass on to somebody else. And when they do pass that document onto their recipient, we want their recipient to have a high level of confidence that the document hasn't been tampered with and was actually signed by the person who it says it was signed by. So the first step in this process is to take a hash of the document, a hash digest, calculate a hash digest of the document. And a hashing function is a mathematical function. We pass the document through a mathematical function that calculates what is effectively a fingerprint for the document. It is a small representation of the document. You pass the document through a function and you get a number out that is of a fixed length, like 256 characters, for example. Now, the good thing about hash functions is that you can take a 1,000-page document, get your 256 character representation of it, now a 256-bit representation of it. If you change one letter in that 1,000-word document, 1,000-page document, and you pass that slightly modified document through your hash function again, you'll get a completely different output. So small changes in the input lead to a very, very different, drastically different output. So this is why you can think of a hash as a fingerprint for the document. So we calculate this fingerprint. And then what we do is we encrypt the fingerprint using the signer's private key. And when I say we encrypt it using a private key, there are a set of mathematical functions that are called asymmetric key functions. And at a high level, these functions have special properties that, among which they have two numbers, where if you pass data and the number through the function, one of these numbers through the function, you get a garbled output at the end. You get an encrypted version of that input. Now, if you take that garbled output and take the second number, special number that's related to that function, and pass those through the function, you get the original input back again. So you decrypt it. So one number encrypts, the second number decrypts. And it works both ways. I can use either number to do either thing. The other really important property of these functions is that even if I have one of these numbers and I have some input and I have some output of passing it through the function, I still can't feasibly figure out what that second number is. That is unique to this function. Now, we call these two special numbers the keys of the function, and we keep one private, we keep one secret, and the signer uses that secret number to encrypt the hash, the fingerprint of our document. Then we attach that fingerprint to our original document, and as well as our public key, and we send it to our recipient. So the document and the encrypted hash go through the network to the recipient receives it, and they can take that same hashing function, pass the document they received through it, then they take what's called our public key, so the second unique number to our function. That's not a secret. We let everybody know what that is. And they decrypt the encrypted fingerprint. If the fingerprint they've decrypted and the fingerprint they've calculated match, then the document is valid. So there are a couple of important steps here. We need to keep our private key very private, and we need to let everybody know what our public key is. And that way we can send documents that we've signed, and people receiving them on the other end can have confidence that, yes, we signed them and the document hasn't been tampered with. So digital signing, at the end of the day, is really about providing confidence in the integrity of a document and the identity of the individual signing the document. But in order to have this confidence, we do need to have confidence in the process, and there are a few steps and things involved in the process. So we need to have confidence in all of those steps and things that are involved. For example, we need to be sure that the private key is private. It's secret. The signer has never let anybody else know their private key. The public key, we have to actually have confidence that it belongs to the signer. I could give you a document with a public key and say it was signed by the President of the United States. You would have to have some way of verifying that this is actually their private key. We have to have confidence that the signer's software used to perform the digital signing is correct. So we have to have confidence in the robustness of that algorithm and how it's been implemented. And certificate authorities fill a lot of the gaps, these gaps that I've just talked about in the public key infrastructure. So what they do, effectively, certificate authorities vouch for the link between the identity of an entity, in this case, our person, our signer, and their public key. So basically they say, yes, this public key does belong to Krzysztof Kot. And if you trust the certificate authority to have done a good job of verifying that, then you can trust that my public key is actually mine. They have processes in place to guarantee or help with private key secrecy and management as well. So they help me, they issue me my private key and my public key, and they help me with their processes make sure that my private key stays private. And how do they do that? They do that through issuing certificates. What is a certificate? This can be thought of as a file that contains both your private and public keys, and that is used by software when signing documents or data. Now recall that the private key is used to encrypt the fingerprint of the document that you're signing and sending, and your public key decrypts it. So there is your version of the certificate that you have that you keep secret and you keep very, very safe that has both your private and public key. And then there are public versions of your certificate that just contain your public key. And so that way, your public certificate can be attached along with a document, and then the person on the other end doesn't need anything else to decrypt the hash and verify your document's integrity. Now, the important thing is that certificates can be chained to establish chains of trust. Much like you sign a document with your certificate, a certificate authority can use their certificate to sign your public certificate. And in that way, they are basically saying, we vouch for the fact that this public certificate belongs to the person or individual named on the public certificate. So the company A, say company A is our certificate authority, uses their certificate to issue you a certificate, your public and private keys, and they sign that for you with their certificate. And that way, everybody knows their public key because they are a public company, and they can verify the integrity of your public certificate and basically say, okay, company A trusts that this certificate belongs to who it says it belongs to, so therefore I can trust this certificate belongs to who it belongs to. So if I trust company A to do a good job of verifying certificate ownership, then I can trust the certificate. Because then I know your public key actually belongs to you, and I have confidence that you've kept your private key private because the CA is helping you do that. So what should be ensured about your certificate to be able to give us this confidence? Now, in the process of signing reports as a professional engineer, because the signature must be unique to the person using it and under their sole control, we really do want a certificate tied to an individual, not an organization, not a department. Yes, certificates can be issued to a department or a company or an organization, and therefore things can be signed on behalf of that organization, department, etc. But the Boards of Engineers requirements state that realistically the signature should be unique and under the sole control of an individual that's performing the signing. So the certificate should be tied to the individual. And that individual's identity needs to be properly verified prior to issuing the certificate, so that the certificate authority can be very confident in saying, yes, this certificate belongs to Krzysztof, or no, it does not, and that we have trust in that certificate authority to have done a good job in that process. And we have to make sure that the private key stays private so that effectively nobody other than the named individual can access that certificate with the private key. Otherwise, it's no longer possible to trust that it was that individual that signed documents with it. So how do I know if I can trust the certificate authority or the issuer of that certificate? And that's a good question, and there is not really one right answer. There are certain standards that exist that companies can be accredited to, and certificate authorities specifically can be accredited to deal with different parts of these requirements. Adobe, Microsoft, and Apple all do run their own audits of companies and compile what are called trust lists. So they look at the processes in place at certificate authorities, and if they find them to be to meet certain requirements that they've set out for security and lifecycle management of certificates, etc., they will put them on a list and say, we trust these certificate authorities to do a good job. So Adobe has the Adobe Acrobat Trust List, or the AATL, and if a company is on that trust list, whenever you open a document in Adobe products that have been signed by a certificate, using a certificate issued by a company on that trust list, Adobe products will automatically trust that signature. Microsoft similarly has a trust list as well, and a document signed with a certificate from the company on the Microsoft trust list will automatically be trusted in Microsoft products as well. Spectra QEST are not a certificate authority. We do not want to be a certificate authority. It is not our core competency. It is not what we're good at. So we've partnered with a third party named Notarius to deliver digital signing feature sets in our products in order to be able to deliver the digital sealing functionality that we have. Notarius is a Canadian company that have been in the business of digital signatures for over 20 years. And they perform identity verification on individuals. They act as a certificate authority in this manner, so they issue the certificates to individuals whose identity they verified. They manage the life cycle of those certificates. They have processes for revocation, expiry, etc. And they also provide the technology that we connect to perform the digital signing action. This is their core business. This is what they do. This is what they have always done. They are a company dedicated to this, and they will do a far better job than we would ever do at being a certificate authority. They've been providing digital signing solutions for engineers for 24 years. And they do offer Microsoft Trust List and AATL personal certificates, so tied to an individual. They are ISO and ADAS certified, And so with a good certificate authority and PKI technology, we've got all the necessary pieces to deliver digital sealing that meets the most stringent requirements. We need a digital signature that is unique to the licensee using it. We will have a certificate issued to the individual with unique public and private keys. It needs to be able to be verified. The individual certificate is issued and signed by a reputable certificate authority where a robust identity verification process has taken place and been carried out. Is under the sole control of the licensee using the digital signature, and so that means the private key is kept private, and there are best practices in place for certificate lifecycle management and ideally multi-factor authentication when signings to access the certificate. And it needs to be linked to an electronic document bearing the digital signature in such a manner that the signature is invalidated if any of the data in the document is altered. So the public key, the digital signing algorithm we talked about previously, allows us to verify that a document has not been modified in transit by decrypting the signed hash and calculating our own hash and comparing the two. So we compare the hash digests. If they match, the document has not been altered, so therefore the signature is still valid. But let's say, so we took a look at examples of requirements around the various states earlier in the presentation. Let's take another look at California. So the Board of Engineers there has pretty lax rules about digital signing. But if you want to do business with the Californian government and you need to provide them digitally sealed documents, they have an approved list of digital signature certificate authorities that they will accept and work with. And Notarius are on that list. Just further cementing home the point that the choice is a good one. But if you are working with the government and providing them digitally signed documents, California ends up in that bucket there. So how it looks in Construction Hive, what have we done to deliver this functionality? After all of that, and after all of that complexity and talking about all those requirements, using this functionality in Construction Hive to digitally seal documents in the capacity of a professional engineer is incredibly easy. Users obtain a certificate from Notarius. They subscribe on their website, go through an identity verification process online using video conferencing, and install their software on their workstation. Then they set up a seal in Construction Hive by uploading an image and setting up its size based on state requirements. And again, this is all based on the requirements of boards of engineers, and we have put presets in state by state to help with that. And then any document can be sealed by pressing a button on the report page, or documents can be bulk sealed from the search results page by pressing a button. The hard bits are all done by Notarius and Spectra QEST. And the output is a digitally sealed document that complies with or exceeds all the boards of engineering requirements around digital seals that exist in the United States. Except in Hawaii, I guess, which doesn't really have any requirements around digital seals except don't do it. Now, side note here, if you are a company that requires digital signing and sealing solutions for engineering folks, even if those people are not using, not digitally sealing construction materials test reports, and the functionality that we built in Construction Hive doesn't necessarily meet their workflow or their requirements, do take a look at Notarius' other product offerings. We ran a very thorough RFP process when looking for a partner for this, delivering this technology, and Notarius were by far and away the most applicable organization to engineers that we found. So if you do have engineering needs around digital sealing, please look up Notarius. So as a wrap up, if you are interested in learning more about the digital sealing functionality or pricing, please do contact Spectra QEST. Thank you for your time, and I hope this has been useful. If you would like more information on how the functionality actually looks in Construction Hive, there is a video on Spectra QEST's YouTube channel that shows off how the functionality actually looks when it's in practice. Additionally, if you'd like more information about digital sealing and signing itself, why choosing a good certificate authority is important, there are some articles that have been published by Spectra QEST on LinkedIn that explain all of that. So check those out if you'd like more information. Otherwise, thank you again for your time. Goodbye.